Imagine peering into the vast tapestry of our Milky Way galaxy, revealing its 100 billion stars in billions of years of history, not in decades, but in mere months. A cosmic revolution is unfolding right before our eyes. But here's where it gets controversial. What if this AI-powered leap challenges our traditional views on scientific discovery? Stick around to explore how machine learning is transforming our understanding of the universe. This groundbreaking achievement comes from a supercomputer simulation that's the most intricate ever crafted of our galactic home. By fusing machine learning techniques with traditional numerical models, researchers have created a program that operates at a staggering 100 times the speed of the most advanced previous simulations. This innovation empowers astronomers to chart the galaxy's evolution over billions of years in just a few months, instead of waiting decades for results. For beginners dipping into astrophysics, think of it like fast-forwarding a nature documentary on cosmic timescales, except now, we can pause, rewind, and analyze every frame with unprecedented detail. At the heart of this simulation lies a colossal representation, 100 billion particles, each standing in for a star in the Milky Way, which, as a reminder, is our sprawling spiral galaxy teeming with that exact number of stellar inhabitants. To put this in perspective, previous high-resolution simulations could only handle about 1 billion stars, and they were notoriously sluggish. For instance, simulating just 1 million years of the galaxy's evolution in fine detail required 315 hours of real-time computing. That's over 13 days straight. Extrapolate that to a full billion years, and you're looking at nearly 36 years of continuous processing on those older systems. It's like trying to watch a slow-motion video of history unfold, only to realize the playback is painfully delayed. What made the older simulations less effective? Each particle in them typically represented 100 stars, which averaged out the finer points. This smoothing effect obscured critical details, such as how a single supernova, a massive star's explosive death, can dramatically reshape the surrounding gaseous environment. Supernovas are stellar cataclysms that release enormous energy, blasting out material and creating shockwaves that influence nearby space. In the grand scheme, these short-term events often drive long-term galactic changes, like shaping the chemistry and structure of the universe. The older models prioritized broad, enduring trends but overlooked these pivotal, star-by-star disruptions. And this is the part most people miss. Without capturing those micro-moments, our simulations miss how individual cosmic fireworks set off galaxy-wide transformations. To overcome this hurdle, the team led by Hiroshima didn't just throw more computing power at the problem, they got clever. They developed a novel approach using a deep learning surrogate model, essentially a trained AI that acts as a shortcut. Imagine teaching an AI to predict the aftermath of a supernova by feeding it high-resolution data on how these events unfold. Over the course of about 100,000 years, a supernova remnant expands into the interstellar medium, that vast space between stars filled with gas and dust. This expansion scatters material, clears pathways, and infuses the medium with newly forged elements from the explosion, like heavier atoms created in the star's core. These enriched clouds eventually collapse to form new stars, perpetuating the cycle of galactic renewal. By mastering these patterns, the AI can simulate these effects swiftly without needing to crunch every tiny detail in real time. Integrating this surrogate model with numerical simulations of the Milky Way's overall motions allowed the team to weave short timescale supernova impacts into the larger, slower-paced galactic story. The result? A simulation that renders 1 million years of evolution in just 2.78 hours. At this pace, mapping 1 billion years, that's roughly the age of our galaxy, would take only about 115 days, a far cry from the 36 years required by predecessors. This isn't just a win for astronomy, it's a paradigm shift. As Hiroshima noted in a recent statement, blending AI with high-performance computing fundamentally changes how we approach complex, multi-layered scientific challenges across fields. Picture applying this to other realms. Tweaking the method could simulate climate change patterns, where localized storms alter global weather, or model ocean currents influenced by tiny eddies that shape vast marine systems. It's like giving scientists a turbo boost for predicting everything from tomorrow's weather to centuries of planetary shifts. In the realm of galactic studies, this methodology promises to revolutionize our grasp of how the Milky Way formed, evolved its spiral arms and central bulge, and built up its chemical richness. We could test theories on star formation, black hole growth, and even the origins of life-sustaining elements. Hiroshima highlighted another exciting angle. AI-enhanced simulations are evolving from mere pattern spotters into true tools for discovery, letting us trace the emergence of life-essential elements within our galaxy without the need for endless computations. The findings from this innovative simulation were unveiled at the prestigious SC25 International Supercomputing Conference, marking a milestone in computational astrophysics. But let's pause for a moment of reflection. Is relying on AI to simulate the cosmos a shortcut that risks oversimplifying the universe's complexities, or is it an essential evolution that democratizes scientific exploration? Some might argue it democratizes access, letting more researchers probe deep questions without supercomputer monopolies, while others could worry about AI introducing biases or inaccuracies in our cosmic narratives. What do you think? Does this AI revolution excite you, or raise ethical concerns about machine-driven science? Share your thoughts in the comments below. I'd love to hear differing opinions and dive deeper into the debate. Keith Cooper is a freelance science journalist and editor in the United Kingdom, with a degree in physics and astrophysics from the University of Manchester. He's the author of The Contact Paradox, Challenging Our Assumptions in the Search for Extraterrestrial Intelligence, Bloomsbury Sigma, 2020, and has contributed articles on astronomy, space, physics, and astrobiology to numerous magazines and websites.